So this is the 2023 Higher Level Applied Maths Leaving Cert paper, question 5. So we have two blocks here, P and Q. P has mass 6.3 kilos and Q has mass 2.5 kilograms. They're held at rest on a rough surface. They're connected by a light inextensible string which passes over a smooth flexible pulley. Block Q lies on a horizontal part of the surface and block P lies on the part of the surface that is inclined at 25 degrees to the horizontal as shown in the diagram. The coefficient of friction between each block and the surface is 0.2. The blocks begin to move when they are released. Show on separate diagrams the forces acting on the blocks which are moving. Okay, so we have P first of all. That's on the inclined part of the plane here, so we have P here. The forces acting on it, okay, so we have a string up along this way anyway, and that has tension in it, and that's tension T. There is friction up along this way as well, so the friction is going to be equal to mu times R, which in this case is going to be equal to 0.2 times R, because mu is, we're told in the question that the coefficient of friction is 0.2. Now R in this case is going to act in this direction, perpendicular to the plane. That's the normal reaction here. And then you have a weight acting in this direction here. And the weight, the mass is 6.3, so it's going to be 6.3 g newtons acting in that direction. So we could just break this down into its component parts here. So we have two vectors going in those directions. This is 25 degrees in here. And here we're going to have, let's see, 6.3 g cos 25 degrees, and down here we're going to have 6.3 g sine 25 degrees. Okay, so that's P. Let's have a look at Q then. Oh, by the way, we have an acceleration as well acting in this direction here. Q then is on a horizontal part of the plane here, and it also has a string in this direction with tension T. It has friction to the right. And again, that's going to be equal to, F is equal to mu times, let's call this one S. So it's in that direction there. We'll call it S, so it's mu times S. So mu again is 0.2, and we've got S there as well. It has a weight then, and the weight, or the force downwards, is mass times acceleration. Its mass is 2.5 and g acting downwards. So that's everything, I think, for both blocks. Let's have a look at the next question then. Calculate the acceleration of the blocks. Okay, so we're going to look at these separately first of all. So we're going to look at P first. So if we look at P, P is moving down the slope. So the only force acting downwards is 6.3 g sine 25. So let's write that down. So we have 6.3 g sine 25 degrees. Now the forces in the opposite direction then are T and friction. So we've got to subtract the T, we've got to subtract the friction, which is 0.2 times 6.3 g cos 25 degrees. So you have 0.2 here, and then we have R, which is going to be the same as this here, 6.3 g cos 25, because the block is not moving perpendicular to the surface. So it has to be equal to the force acting against it, which is 6.3 g cos 25. Okay, so all of that then, they're all our forces, so we've got to let that equal to mass times acceleration. Its mass is 6.3, and the acceleration is what we've got to work out. So when you simplify all of this, you can do this and this on your calculator and subtract them. When you do all of that, you get 14.90136293. You've got a minus T, and that's equal to 6.3a. This is equation number 1. Let's have a look at Q then. So same thing for Q. So if we look at Q here, Q is going to move to the left. So we're going to put T first, and then we're going to subtract the friction. So T is first, and then we're going to subtract the friction. So that's 0.2 times the normal reaction here, S, which is going to be the same as 2.5 G, because again the block isn't moving perpendicular to the surface. So it's 0.2 times 2.5 G. That's equal to mass times acceleration, so that's 2.5 times the acceleration. So simplify that, you get T minus 4.9 is equal to 2.5a. This is equation number 2. So I'm going to take equation 1, just put it underneath here. So it's minus T plus 14.90136293 is equal to 6.3a. This is equation number 1. Add these two equations, so the t's will cancel, you'll get 0. And when you add the two numbers then, we'll get 10.00136293. Add the right hand side, we'll get 8.8a. All we've got to do now really is just divide across by 8.8, and we'll get 1.136518, and that's meters per second squared. That's our acceleration. Okay, so let's have a look at part B then. Anya travels by car from her house to work each morning. On Monday morning, she starts her car and accelerates uniformly for 40 seconds to a speed of 22.5 meters per second. Anya then travels at this speed for 8 minutes until decelerating uniformly to rest at her work, and she reaches work at 8:30. On Tuesday, she does the same trip again, but she leaves the house 140 seconds later than the day before. She takes the same route to work. She starts her car and accelerates at 1.5 meters per second squared for 20 seconds, maintains a steady speed for 6 minutes before decelerating uniformly again to rest, and she arrives at work again at 8:30. Calculate the time when Anya leaves her house on Tuesday morning. Okay, so what we're going to do here is we're going to have a look at Monday and Tuesday separately, and we're going to draw a speed time graph for each day. So this is speed here, and this is in meters per second. This is time down here, and this is in seconds. So she starts off on Monday and reaches a certain speed, maintains that speed, and then decelerates. Now let's see, she starts her car and accelerates uniformly for 40 seconds. So she's going to accelerate uniformly for 40 seconds. So it's 40 seconds from here to here. She travels at this speed for 8 minutes. So 8 minutes is 480 I should say seconds. So that's going to be from here to here, 480 seconds. And then she decelerates for a certain time. We don't know what that time is, so I'm just going to put in X here. And she arrives in work at 8:30, so this is 8:30 down here. Now she maintains this constant speed, which is 22.5 meters per second. So this is 22.5 meters per second here. So there's our Monday anyway. Let's look at the total time that she spends traveling. Well, she travels for 480 plus 40, that's 520, plus another X, which we don't know, so that many seconds on Monday. Let's have a look now at Tuesday. So we've got to do the same thing again. So we'll just draw another speed time graph here. Again, this is speed in meters per second. This is time down here in seconds. She accelerates, she maintains a certain speed, and she decelerates again. So let's just break it down here again into two triangles and a rectangle. Now she accelerates initially for 20 seconds and the acceleration is 1.5 meters per second squared. So this is 20 seconds here, and this is 1.5 meters per second squared accelerating. So if she's accelerating at 1.5 meters per second squared for 20 seconds, her final speed then, if you just take her final speed if you like, is going to be equal to 20 times 1.5, which is 30 meters per second. Because really we have meters per second squared, and we're multiplying that by seconds, so that's meters seconds over second squared, which is meters per second, which is speed. Okay, so in other words, this here is going to be 30. So we have her final speed that she's going to maintain for, how many seconds does she maintain that for? For 6 minutes. Okay, so that's 360 seconds. So you've got 360 seconds here. And then finally, we don't know what this time is down here, but we know that she arrives at 8:30 again. So let's look at her total time. So her total time then is going to be the same as Monday, but she leaves the house 140 seconds later than the day before. So it's going to be the same because she arrives at 8:30. She left at 140 seconds later than the day before. So it's going to be 5:20 plus x. That's the time it took her the day before, 5:20 plus x. And we've got to subtract 140 seconds. So when you do that, you get 380 plus x. So that's the time it takes her to reach work on Tuesday. Now, if you look at that, where does this 380 come from? Well, we just subtracted the 140 from 520, but if you look at Tuesday here, we know that she traveled for 20 seconds. We know that she traveled for 360 seconds. So that's actually 380. So that means this must be x out here at the end, which is very handy. So what I'm going to do next then is we've got to find the time Anya leaves her house on Tuesday. So what I'm going to do is look at the distance in both cases and equate them. The distance is the same in both cases because she travels from home to work and she travels the same route. So to find the distance that she's traveled, all you've got to do is find the area underneath each curve. So in other words, the area underneath each graph must be the same. So what we've got to do is find the area of these two triangles plus the rectangle, and that will be equal to the area of these two triangles and the rectangle. So let's write all that out. So in other words, what I'm saying here is the distance is the same. That implies then that the areas are the same. So all I've got to do is find the area underneath each curve. So first one is going to be half the base times the height. So it's half of 40 times 22.5 plus the area of the rectangle in the middle, which is length by width, 480 times 22.5 plus the area of the triangle at the end then is just going to be half times x times 22.5. All of that is equal to the area of our second curve on Tuesday. So that's half of 20 times 30 plus the rectangle in the middle is 360 length times width times 30 plus the triangle out at the end, half of the x again times 30. Now this is all just calculator work at this stage. So all you've got to do is work all those out on your calculator. What you'll get is 450 plus 10800 plus 11.25x is equal to 300 plus 10,800 plus 15x. Now at this stage, bring all the numbers over to the left-hand side. You'll get 150. Bring the x's over to the right-hand side. You'll get 3.75x. Divide now by 3.75. and you'll end up with 40 seconds. Okay, so we know what X is. So we know what X is here on Tuesday. So the question is, calculate the time when Anya leaves her house, I should say, on Tuesday morning. So we know now the full time that it took her to go from home to work. So we add 360 plus 20 plus 40. So the total time on Tuesday then, time taken to get to work on Tuesday is 420 seconds, which is 7 minutes. Now, what time did she leave then at? Well, if she got in at 8:30, so if she got in at 8:30, our answer then is just going to be 8:30, and we've got to subtract 7 minutes. Subtract 7 minutes, that means she left at 8:23. Hours are 23 minutes past 8. And that's it for this question.